Hello everyone, this is Meedhansh and welcome back to the Java series. Today we are going to cover the topic operators. We are going to know about the operators which we have available in Java. So let's dive right into our topic operators. Okay, so here I am on the presentation. And as the name says, the operators, so we are going to discuss about the operators which are available in Java. So operators are very necessary in any programming language. It can be C, C++, Python, PHP. In every programming language, operators are required. So let us see what are operators and how are they essential. Basically, operators are used to perform operations on variables or values. As we discussed in the previous lecture, variables which store value, so we can perform either the operation on the variable or directly the literal or value. And there are 5 major categories of operators which are available in Java. Mostly there are 5, but it might vary for some programming languages as there are different operators in different programming languages. But most of them are same. So let us see which type of categories we have. So we have 5 categories, and the first one is the assignment operators, then arithmetic, comparison, logical and bitwise operators. So let us understand them one by one. First of all, the assignment operator. So in the assignment operators, the one is the simple assignment operator, which is the equal to sign that assigns value from right to left. Let's say we have a statement A is equal to 100. So in this case, we have the 100 as the value which we are assigning to the variable A. And then there are many more types of assignment operators, and they are basically the shorthand notations for common assignments. Their shorthand notations can be used for the arithmetic operators and the bitwise operators except the complement operator. So we will see that how we can use the assignment operators for these two different categories of operators. So then we have the second category, which is the arithmetic operators. So here we have a list of 7 operators. First is the plus, addition, then subtraction, multiplication, division, modulus, increment and decrement. So we all know that the use of the first 4, which is the plus, minus, multiply and divide. So we have a different sign, the asterisk for multiplication and the slash for division. There's another one which is modulus. So we will know that how modulus and all of them work. And then we have the increment and decrement operators. So as we discussed in the assignment, we have the shorthand notation. So for these, we have the shorthand notations for the first 5 till the modulus. So how does it work? It is basically like the plus equal to or minus equal to. So if we have a statement A is equal to A plus 10, make it sure that both of the sides is A or the same value. So A is equal to A plus 10. So we can simply write it as A plus equal to 10. It represents the same statement. Now let us take a look at some of the examples. So we have the variables int x is equal to 20, then y is equal to 10. So we have two variables defined, and we will perform the operations on both of these variables. So firstly, addition, we know that x plus y, which is 20 plus 10 is equal to 30. We will get the answer. Then subtraction, answer is 10. For multiplication, it will be 20 multiplied by 10, which is 200. Then for division, we have x divided by y, which is 20 divided by 10. We will get the answer 2 as the quotient. Now here the modulus works and gives the output the remainder. And modulus is mostly used in the programs where we need to check that the number is even or odd. So if the number is odd, it will give the remainder 1, or if the number is even, then it will give the remainder 0. So over here we have two values, both of them are even numbers. So 20 divided by 10, it is still divided. So 20 divided by 10 or 20 module 10. So the answer will be 0. which is the remainder. So 20 divided by 10, the quotient is 2. And if we want the remainder, then we have to use the percentage sign or the modulus operator. We have two more arithmetic operators as discussed, the increment and the decrement. So let us see how they work. In the increment and decrement, we have the differentiation over here, that in both of these operators we have post and pre. So let us see how they work. So we have another data set which is variable int x is equal to 10. So we have the value 10 over here. Now I have simply written print over here, but if we are working in Java, then we have to write system.out.println. But just for understanding, I have simply written print over here. So when we print plus plus x, plus plus which is before x or the variable, so it is the pre-increment. So the value we get is 11. How? Because we incremented the value of x and we got the value 11. Previously it was 10. And this operation, firstly, this operation will happen. The x will be increased by one number and then it will be printed. So that's why we got the value 11. In case of the post increment, when we print x plus plus, so in this case, firstly, the pre-retained value of x, which is 10, will be printed and then it will be incremented. So if we print the x again, we will get the value 11. But for now, if we are performing the post increment, then we will get the value 10, because it shows the original value first and then it will increment it for the other operation. Same with the decrement. If we are doing the pre-decrement, first it will decrease the value by 1 and then it will print it. So we got the value 9. 10 minus 1 is 9. And if we are doing the post decrement, in this case, if we are printing it x minus minus, so we will get the value still 10, because we got the original value first of the variable and then the changes to the variable are made. Then we will, if we print the value of x again, so we will get the value 9. But for now we will get 10 because it showed the original value. So this is how the arithmetic operators work. Now the second category is the comparison operator. So as the name says, we have to compare two values in these, and these operators return true or false as the output. So we have again 6 operators over here. So first is equal to, which is basically the double equal to, which shows that both the values are equal to each other. Then, because in the assignment we have a single equal to, so that represents the assignment, that this value is being assigned to a variable or another value. So that is why we are using double equal to over here, which represents the equal to for the comparison operator. The second one is not equal to, means the value A is not equal to B. Then greater than, less than, greater than or equal to, and less than or equal to. Let us see the examples. Again we have the same data set, int x is equal to 20 and y is equal to 10. So if we perform the first one, which is equal to, so x equal to y. So is it true that 20 is equal to 10? No. So we will get the output as false. So x equal to y, which implies false, because it is not true. 20 is not equal to 10. Then we have not equal to operator. So we will put x is not, exclamation mark is used for not. So not equal to y, which is true because 20 is not equal to 10. Then the greater than operator. So x is greater than y. Yes, 20 is greater than 10. So we got the value true again. Then less than. So x is less than y. No, 20 is not less than 10. So we got false. Greater than or equal to. So x is greater than equal to y. It is true. Even if the value in x and y could be the same, as the int x is equal to 10 and y is equal to 10, then also we were going to get the true value, because we have the greater than or equal to. If they are equal, it will still return the true value. Then less than equal to, it works the same. So x is less than equal to y. So it is not less than or equal to y. So we got the value false. Now the fourth category, which is the logical operators. We have just three operators and they also return true or false as the result. So we have the logical AND, which is double ampersand. Then we have the logical OR, and then logical NOT, which is the exclamation mark again. Exclamation mark in programming simply says that it is the NOT operator. Either it can be logical or it can be used in the comparison as well. So let us take a look at the examples. We have the variable int x is equal to 10. So logical AND, we are using the first logical AND. So x is less than 10 and x is less than 15, which is false. How? The logical AND returns true only if both the statements are true. If x was less than 10 and x was less than 15, only then it could have been the result was true. But for now it is false because x is equal to 10. If we put here x is less than equal to 10, then we get the value true because x is equal to 10 also and x is less than 15 as well. Then the logical OR, x is less than 10, again we are using the same one. So which is x is less than 10 or x is less than 15. So we got the output true. Why? Because logical OR returns true if one of the statements are true. In the case of AND, both statements must be true. But for the logical OR, only one statement needs to be true and then the total output will be true. In this case, x is less than 15. So this statement is true, the other one is false. But since one of them is true, so we got the answer true. Then we have the logical NOT. So we have a different way to show it. So NOT, then in bracket, x is greater than 15. So x is greater than 15? No. So it is false. But NOT is also known as the reverser of result because we got the result as false inside the bracket because we firstly solve the bracket. So according to the bracket, the answer is false, but the not sign converts it into the opposite of the result. So we got the answer true. So basically the statement or the sentence will be that x is, so the not x is greater than 15 or x is not greater than 15. So logical not reverses the result, makes it false if it's true. And since it was false, so it made it true. Then we have the last category, which is the bitwise operators. Over here also the assignment operator can work as the shorthand for all of these except the bitwise complement. We will know why. So firstly we have the bitwise AND, bitwise OR. We do not have to confuse it with the other one because over here we have the single symbol only, ampersand, there's single OR, and then we have the bitwise XOR. Then bitwise complement, left shift and right shift. Left shift operator is also known as multiply by 2 and right shift operator is also known as divide by 2. We will know why it is known as the multiply and divide by 2. So firstly, the AND operator for the bitwise. So here we have a truth table and we have this statement int x is equal to 150. So we are going to execute this statement. Now what do you think will be the answer? You might be thinking 150 or 150 or the same value will be retained or just the 100 or just the 50. But let us calculate how we will get the exact output. So the binary comes over here as the name suggests, they are the bitwise operators. So according to each bit, we are going to compute the answer. So we have the 100 is greater over here, but it doesn't matter. So 100 and the maximum would be 64, as we learned how to convert the decimal to binary. So we will simply convert the 100 into binary first. So we will go maximum till 64, because if we double 64, we will get 128, which exceeds 100. So till 64, we will put a 1 for 64, then 1 below 32. So it is 96. Then we require a 4, so we put a 1 below the 4, and rest of them will be 0. Same for the 50. So we have the 32, then 16, then we have the 2, which makes up a total of 50. Now, according to this truth table, we are going to compare the values of the 100 and the 50, the binary value. So let us start from the right. First off, we have 0 and 0. Both of these values are 0. So according to the truth table, 0, 0 is 0. 0, 1 is also 0. 1, 0 is also 0. And 1, 1 is 1. So if we want to remember it easily, so we can say that 1, 1 is 1. Rest of the combinations are 0 for the AND operator. So in this case, 0, 0, 0. 0, 1, 0. 1, 0, 0. Again 0, 0, 0. 0, 1, 0. We just have 1, 1 over here, which is the, like, below the 32, both of them have it. So 1, 1, the answer is 1. Then again 1, 0, 0. So the resulting output is 0, 1, then again 5 times 0. So the answer will be 32. Because this binary code converts into 32, because 1 is just below 32 and nowhere else. So therefore x is equal to 32 is the answer. Then we have the OR operator. So we are going to execute the same statement but with the OR symbol. We have a truth table for this as well, and we have the binary. It's the same binary, 1, 1, 0, 0, 1, 0, 0 for 100, and then 0, 1, 1, 0, 0, 1, 0 for 50. So now we are going to compare these again. So now according to the truth table, we have 0, 0, 0, and rest all combinations make it 1. So 0, 1 is 1, 1, 0 is 1, and 1, 1 is 1. So let us just compute it. Now, starting from the right, 0, 0, 0, because the truth table says that 0, 0 is 0, rest of them are 1. So 0, 1, 1, 1, 0, 1, again we have a 0, 0, so the answer is 0. Then 0, 1, 1, 1, 1, 1, and then 1, 0, 1. Wherever there is 1, 1, so we will get the output as 1. This might be a little confusing if I am saying 1, 1. So please try to understand how we are saying this. So basically we have just a single 1 over here. So if we have even a single 1 in both of these, so the resulting output will be 1 below that number. So the output for this is 1, 1, 1, 0, 1, 1, 0. So this binary converts into the decimal as 118. Let us just calculate. Then 64 plus 32 plus 16 plus 4 plus 2, which makes up the total 118. So therefore the value for x will be 118. Then we have the XOR operator. We will execute the same statement again. Now this might look like 100 raised to power 50, but in this case 100 XOR 50 is the statement. We have the truth table, the computation. So again the same binary, and now we are going to compare in a different manner, as we did the different manner in the AND and OR operator. So here the truth table says that the similar bit will result 0 and the dissimilar bit will result 1. So 0, 0 is 0, 1, 1 is 0, 0, 1 is 1, and 1, 0 is 1. So let's compare. 0, 0, similar bit 0, 0, 1 is 1, dissimilar, again dissimilar, 1, 0, 1, 0, 1, similar bit 0, 0, 0, 0, 1, 1, 1, 1. It's similar. Don't write 1, 1 is 1, 1, 1 is 0. 1, 1, 0, because they are similar. Both of these are similar bits. These are all the bits. Okay. So below the 64, 1 0, again 1. So the pattern of OR and XOR is a bit similar. So therefore this pattern, which is 1 0 1 0 1 1 0, results into the output 86 as the decimal. So therefore X is equal to 86. Those are a quite unexpected value, but we have to compute them like this so that we can get the result, or we can say we have to calculate them like this. Now comes the fourth operator, which is the complement. In this case, we don't have two operands, we have a single operand. So complement, which is a tilde operator, so tilde 100, and we are going to execute this statement. So we don't require a truth table because we are not going to compare the values. Simply what we are going to do is, if the bit represents 0, we are going to change it into 1, and if it's 1, we are going to change it into 0. So as simple as that. So the binary for 100 is as follows, and starting from the right, it's not necessary to start from right, we can start from anywhere because we will get the same output. So 0 converted into 1, again 0 is 1, 1 is 0, 0 1, 0 1, 1 0 and 1 0. So we have the 1 under 16, 8, 2 and 1. So technically we get the answer as 27, but it's wrong. How? These are a total of 7 bits over here, and as we see the output or the result, that we have the 110, 11 and then is equal to 27 as the decimal. But actually these are just 7 bits, and keep an eye on the data type. The data type over here is int. So how many bytes does int occupy? It occupies 4 bytes. So 4 bytes are 32 bits. So what about the rest of them? These are just 7. So there are 25 more bits left, and all of them are 0 by default. So if we convert all of them into 1, so it will be a really huge number if we will just plus them, because we are just going to the 2 raised to power 32, which is in billions. So to make it simple, we will take the byte data type. So byte x is equal to complement of 100. So now, since it is byte, it will occupy 1 byte. So we will take the bits from 1 to 128. So these are 8 bits in total. So now let us start calculating it again. So 0 is 1, 0 is 1, 1 0, 0 1, 0 1, 1 0, 1 0, and then the 0 which was additional over here because of the data type. So the 0 is also converted into 1. So we have got the 128 as the number extra to be added into 27. So therefore now we have the 1 0 0 1 1 0 1 0 0 as our result, and we will get the answer as 155. So 155 is the correct answer, as we are taking the byte as our data type. If we take int, so it will be a really huge number, so that is why I was just executing the byte instead of the other one. So therefore x is equal to 155, and the data type has 8 bits, so 8 bits for byte data type. Now the next one, it is the left shift operator. So we have this statement, index is equal to 100, left shift 1. 1 over here is representing the position which needs to be shifted. So we are going to shift to 1 position for each of the bit for the binary of 100. So again we got the table, and we will take the 8 bits over here. So we have the binary for 100, and now we are going to shift each of them 1 position, so towards the left, because we are using the left shift operator. So if we shift all of them, so we get this binary, 11001, then 3 times 0. And now if we sum them all, we get the answer 200. So the binary converts into the number 200, and therefore x is equal to 200. And as I mentioned when I was introducing you to the categories, so in the bitwise we have the left shift, also known as the multiply by 2. So if we multiply 100 by 2, we get the answer 200, and this is the same thing which happened over here. And if we keep the position as 100 left shift 2, so what will happen? First, if it will be shifted once, so we will get the answer 200, and then the binary of 200 will be shifted again one side, so 200 into 2 will be 400. So if we left shift twice the 100 value, we will get the answer 400, and this is how it continues by shifting one bit towards the left. Now we have the right shift operator. So in the case of right shift, we will put this, which is 100, right shift 1. So 1 is the position that needs to be shifted towards the right. So we get our table, and the table we have 8 bits again over here. They are not necessary, but I still took the 8 bit for easier understanding. Although we could have took the 7 bits as well, we could have removed the 0, but for a little better understanding, we are going to take this 0 as well. So the binary of 100, we have it over here, and we will now shift them towards the right. So we will shift all of them like this. And you might be thinking that this 0, where will it go? Because we do not have the 0 or -1 value over here in the bit. So it will be disposed of. This 0 will be disposed of. That is why I put the arrow outside of the table. So the result will be 110010. So the answer will be 50. So 32 plus 16 is 48, and 48 plus 2 is 50. So now 100 divided by 2 is 50, and that is why the right shift operator is known as the divide by 2 operator. So if we ever get the question that 100 right shift 1 or 100 left shift 1, so instead of just calculating it this way, we can save our time and we can just simply multiply it by 2. And if we have more than 1 as the position, let's say the position is 2, which needs to be shifted, then we will shift it once first, and basically we will multiply it by 2 first, and then that value, that is 200 in case of the 100 as a value, so we will again multiply 200 by 2, so we get the answer 400. So in this case we divided it by 2 and we got the answer as 50. So x is equal to 50. And those were all our operators which could be used, and the arithmetic and the bitwise can be used as the assignment also in the form of the shorthand notation, except the complement, because there are not two operands. And from the operands we have some groups also in operators. So we can simply classify the operators into 5 categories or 3 groups. So these groups are, firstly, the unary operators. The unary operators perform operation on a single operand. For example, x plus plus, x minus minus, complement of x, not x, etc. So x plus plus, we just have the x over here. We do not require any other operand. So x plus plus, which will simply return the value, and then it will increment it. Then we have the second operator group, which is the binary operators. Binary doesn't here mean that the bit. It means that 2 operands are required for the operation. For example, x plus y, a multiplied by b, p and q, the bitwise and, etc. So 2 operands are required over here in the case of binary operators. Then we have a third special category of operators, and there is just one operator in this category, which is the ternary operator, which performs the operation of 3 operands. So for example, we have a statement over here, z is equal to, then in brackets, x is less than y, question mark 100 colon 200. Now this seems a bit complicated, so let's break it down. So here, let us just forget about the x, z equal to, first let us just calculate this, the right part. So in the brackets, if let's say x is equal to 20 and y is equal to 10. So is x less than 20? Is x less than 10? Basically, is x less than y? So 20 is not less than 10. So that is why it returns the value false, because the comparison operators and the logical operators return the value true or false. So if it's false, then the value stored to z will be 200, because the left side of the column represents the true value and the right side represents the false. So it is somewhat similar to the if else. It is the short form of the if else statement. So if it is true, then this value will be assigned, and if it is false, so then 200 will be assigned. And if x was 10 and y was 20, so 10 is less than 20, then the value 100 was going to be assigned to the variable z. So let us summarize that what we have learned today. Basically, we learned about different categories of operators, which includes the assignment, arithmetic, comparison, logical, and bitwise operators. Then we learned about the operator groups. We can classify operators into three different groups. First are the unary operators, which require one operand. Then the binary operators, which require two operands to perform an operation. Then there is a special type, which is the ternary operator. There is a single one, and this is the operator. So question mark and colon represent this operator. So that is it for today. I hope you liked the video, and if you have any questions related to the operators, you can comment down below. So thank you very much for watching, and I will see you in the next one.